Welcome, everyone. Glad to have you here at our webinar, and welcome to Geography Awareness Week. Here's a fun fact. Arizona has had 6 state climatologists, and all 6 of us have been trained in geography. We're all geographers. Geography is not about memorizing state capitals, but instead, what we do is we look for patterns. Where's it going to rain? What's happening with the clouds? What do the models say? What's the antecedent soil moisture look like? All of that really helps determine things like where will flash flooding occur. And so that's really how we think as geographers. You should definitely try to take a physical geography class if you can. You'll understand what's happening around you. But it might seem odd. What we're going to talk about next is looking at atmospheric rivers. Arizona can absolutely be impacted by atmospheric rivers. Just for a definition, an atmospheric river is like a fire hose of water. It hits the coast. It hits our west coast here in the United States. These do happen for every continent, even Antarctica, and they're typically a winter event. They tend to happen more during El Nino events, but not always. As long as the atmospheric river hits in just the right location and just the right direction, Arizona can definitely be impacted by that precipitation. You may recall the very wet winter we had in 2023. Well, that was started off by several atmospheric rivers in December 2022 and January 2023. Right now, there's a large atmospheric river. It's currently impacting Northern California, but that's not really going to impact us here in Arizona. However, if that snowpack can move into Wyoming or Utah, it might help the snowpack of the upper Colorado River Basin, and that then could help Arizona. What's interesting, next week, it might be possible for Southern California to get an atmospheric river, but we're going to have to wait and see what happens. We'll look at this instead. This fall, Arizona experienced the longest record-breaking heat wave ever in the United States. Several heat records for daytime temperatures. They were broken not only in Arizona, but all over the West and Southwest. And that heat wave ran from September 24th to October 14th. Phoenix broke the record for the longest consecutive maximum temperature records or ties ever. That was 19 new maximum temperature records and 2 ties consecutively. Tucson had 18 new maximum temperature records. Flagstaff had 10 new maximum temperature records as well. So when we look at that, the previous longest record-breaking heat wave, that happened in 1936. It was in Iowa, and they had 14 consecutive maximum temperature records. So we definitely broke that. The significance for the Phoenix records, not only just the length of consecutive days, but also some of the previous heat records that were broken, they were broken by 8 or 9 degrees. Heat records more often are broken by just 1 or 2 degrees. So this was definitely a significant event. Because of the heat wave, October started very dry, but once the heat wave broke by mid-October, we were able to get some storm systems into Arizona. So there were actually good amounts of precipitation in Coconino, Navajo, Apache, Yavapai counties. But if you look down south, Pima, Santa Cruz, Yuma, they all ended up being tied for their driest October, which was 0, the big goose egg on getting any precipitation. That's actually not unusual when you look at this after, the 3 statistically driest months of the year. Those are April, May, and June. November ends up being the 4th driest month of the year. October is statistically the 5th driest month of the year. So not unusual to see that. This month, November, cold fronts were able to dive down into Arizona. Grateful for that. They dropped temperatures across the state. You can see the mean temperature departure from normal. Temperatures across the state are below normal, which is amazing to see. Tucson went from no precipitation last month in October to above average precipitation this month. They only had one event so far. It was on the 3rd, but it was a significant event. Phoenix had a couple of days with trace amounts of precipitation this month already. And of course, Flagstaff's, they've gotten snow already, but they're still below average for amounts for the month. There's some good precipitation so far in the southeastern and eastern counties, so that's good. Most of the state, though, is still well below average precipitation for the month. We know that can always change if we can get some more systems, but unfortunately, we'll have to wait and see. This year, so now let's look at January through October. So we're starting to look at annual amounts. This year, January to October was the 3rd warmest January to October on record. 2020 was the hottest. 2018 was the 2nd hottest. In fact, it's been a really hot decade, and 5 of the hottest January to October records happened this decade since 2015. While our monsoon season this year was below average for most of the state, you may remember that at the end of June this year, we actually had thunderstorms and an early start to the monsoon. June is statistically the driest month of the year, so any precipitation that happens in June can really pop into hugely above average ranks. This June had about 1/2 inch of rain statewide, and that ended up with this June as the 19th wettest June on record. And then looking at January to June, that was the 27th wettest January to June. So that wasn't a bad thing. Let's pop in and look at the water year. So when we look at a water year, remember that's how we manage water, and it runs from October 1st to September 30th. So we're looking at water year 2024 that ended at the end of September. And then looking at statewide water year 2024 precipitation, we ended up with 10.65 inches. Yep, 10.65 inches. And that was 87% of the long-term average. The long-term average, when we're looking at water year precipitation, is just over 12 inches. So it's not a lot. And when we drop down, you can really see that difference. Some weather stations did great for the water year, especially in Pima and Pinal counties. Even Yuma and Apache counties did good. But Mojave County had its 11th driest water year. And looking at that, La Paz, Yavapai, Coconino, Navajo counties, they all ended with really low amounts for the water year. As we're getting started on our winter 2025, let's hop back and look at this past winter in 2024. By the end of this past April, precipitation had ranged from 70% to 200%, and that's going across the upper and the lower Colorado basins. In winter, we look closely at snow water equivalent, and that's also called SWE. We'll talk about it as SWE. Snow water equivalent helps measure how much overall water has dropped in the form of snow. So we also look at median melting times for the upper Colorado Basin for this last winter. And in general, it's usually early April. For the lower Colorado Basin here in Arizona, it's usually early March. The lower Colorado basins in Arizona reach their peaks this past winter in early February. You can see it on the charts. It just kind of pops up right there. But then in April, we had some additional events. So we had additional snow. You can see it popped up again in April. So it actually extended the season a little bit. Not so bad. We'll see what happens this year or this winter. Next, let's pop back and review what happened with short-term drought in water year 2024. Water year 2024 started with 45% of the state in moderate or severe short-term drought, and 6% of the state was in extreme short-term drought. So those are those colors that you're seeing there, kind of the oranges, and extreme drought is going to be that red. You'll see that there. Most of that was typically in central, eastern, southeastern counties. Our winter, last winter, eliminated that extreme short-term drought, decreased moderate and severe short-term drought, and that was set up before summer. Unfortunately, the summer being very hot, very dry, We saw that moderate and severe short-term drought increased across the state to 40% of the state. And that was largely in western, central, southeastern counties. Because the state remained hot and dry, extreme short-term drought has now expanded to 8% of the state. It's over there you can see it in Mojave, La Paz, Yuma County, a little bit of Maricopa County, tiny little bit of Yavapai County right in through there. The last time the state had this amount of extreme short-term drought was 2 years ago. The really dry monsoon in western and central counties definitely helped advance that short-term drought in those areas. And now let's take a look at our long-term drought. Meteorological summer runs June through August, and Arizona had the hottest meteorological summer on record, and that's out of 130 years of record. This was also the hottest September and the hottest October on record for Arizona. Arizona has also had mostly dry summers for the last 2 years. When we're looking at our long-term drought, we evaluate the last 24, 36, 48 months for Arizona. And when we look at the long-term temperatures, the long-term precipitation for the state, we see that Arizona's been in drought since 1994. You can see on our map that extreme long-term drought has expanded across most counties. Exceptional long-term drought increased in central and southeastern counties. So just a heads up that this is our last webinar for this year. We'll start up again in January. We're grateful to have a guest speaker, Joe Casola, today from the USGS. More than anything, USGS focuses on earth and water, and because of that, supports really vast environmental issues. Joe's an atmospheric scientist. He can bring a unique interdisciplinary perspective to the agency. Welcome, Joe.
Oh, thanks. And thanks so much for having me. Let me try to share my screen here. Hopefully my slides are showing. So today I just want to walk through the outlook for the next few months, what we think the climate might bring us, as well as talk a little bit about a project called ASSIST that we have here at the U.S. Geological Survey, and I'll explain what that acronym represents. So we'll start looking at the shortest lead time, the 8 to 14 day outlook, so just a little bit past our weather time scale. And on the left is a map showing the odds that we anticipate for temperature being a little bit either cold or warm. And on the right is the odds for precipitation being a little bit dry or wet. And you can see that the odds are tilting, leaning towards a little cooler than normal for the next couple weeks, so the end of November and the beginning of December. And a slight tilt towards continued dryness. And I'll show you why that may be the case. I looked at a long-term weather model, which should always be taken with a grain of salt when you're out kind of at the 10-day period. But the little hint here, I think, to keep your eye on is this little ridge that I put a square along. And let me explain this map for a bit. The black lines are what we call geopotential height. So they kind of give you a sense of the flow in the kind of middle of the atmosphere, the flow that steers storms. The colors relate to vorticity, which I'm not going to really talk about. And you can see little wind barbs there that show you the wind. So if this setup happens, which this model is suggesting, if this ridge sets up just kind of along the west coast of North America, then you would expect kind of a trough could form a little bit farther east, and that brings a lot of cold air down from Canada and could keep things kind of a little bit colder than average in the Southwest, including Arizona. That would also, if that flow sets up that way, also probably be dry, that it's hard, that air that's kind of coming from continental North America tends to be pretty dry, as opposed to some air that might be sitting over the Pacific Ocean. So this is, I think, the pattern that you would want to keep an eye on and see if it actually sets up. It's very sensitive, right? If you move that ridge just a little bit east or west, you could have very different weather in the Southwest. So for those who are weather watchers, this is the thing, I think, to keep an eye on for the next couple weeks. Now, going a little farther, looking at kind of the rest of the winter, the main predictor that we have is the state of either El Nino or La Nina, and those just refer to, I'm sure you've heard about it in the press or in weather discussions, whether or not it's kind of warm or cold in the equatorial Pacific, and that kind of anomaly with ocean temperature can set off kind of a domino effect, like a chain reaction that affects the jet stream in our weather in North America, especially in Western North America. So this plot shows season by season. So across the x-axis, across the bottom are 3-month averages. So OND is October, November, December. NDJ is November, December, January, and so on. And it shows us what NOAA is thinking is the chances for an El Nino or a La Nina, or the in-between, the neutral. And you can see as we go into the winter, the chances for La Nina grow. And I should say right now we are technically in a neutral state. We were in El Nino last year, and so we're kind of transitioning out of it. And so a lot of these longer term models that look at the Pacific Ocean, as well as the the atmosphere above it, are calling for a shift into La Nina, with a pretty good chance that kind of sets up shop in the middle of the winter. Now, this is another depiction of what some of these longer term models say about that La Nina. And there's a lot of lines here, but the basic story is that the La Nina is expected to be pretty weak. So you can see kind of a horizontal line at 0. That would be, and these correspond to how warm or cold it is in the Pacific Ocean. So 0 would be neutral. You can see dotted lines at 0.5 and -0.5. If the Pacific Ocean gets warmer than 0.5, we're in an El Nino state. If it's colder than -0.5 for a while, not just momentarily, but for a while, then we're in a La Nina state. And you can see that a lot of the models don't get much colder than about 0.5 degrees Celsius in the Pacific Ocean. So we expect this to be a pretty weak event. And when you have a weak event, the response in the atmosphere tends to be, we have less confidence that the atmosphere kind of kicks in to a La Nina state. So you may ask, well, what does a La Nina state look like in the atmosphere? So these are really popular cartoons that we often use to differentiate between what happens to the jet stream that affects North America for an El Nino, which I show at the left, and a La Nina at right. And so when we have an El Nino, it's kind of like, if you can imagine the jet stream's like a big fire hose, it's like we have a whole bunch of firefighters holding that hose, and we tend to keep the jet stream kind of pinned down in the southern tier of the continent. That usually brings more moisture to kind of the southwest as well as the southeast, and it robs moisture from a lot of the northwest. And I think Erin Ann's picture of some of those atmospheric rivers in last year, in water year 2024, that was an El Nino year. So you saw kind of a lot of activity with that kind of towards the southern chunk of the West Coast. Now, where we're headed, or where we are predicted to be headed, is a La Nina, and so you have more variance in the jet stream. So, in this particular cartoon, it shows the jet stream obviously being farther to the north and having a little bit more wave to it. But I like to think of it, which I think is accurate, but I also like to think of, take those firefighters away from the fire hose. So now the fire hose can kind of do what it wants, and you can have a variety of ridges and troughs that get set up. The net effect of that is a lot more moisture, and usually cooler conditions are in the northwest, and the southern tier of North America, including the southwest, tend to be a little drier than normal. So you'll see this reflected in the next 2 plots that I show. So looking at where we think things might head in December, On these are again these odds maps, these probability maps. So on the left it's temperature, on the right it's precipitation, and you can see that the odds are tilting towards above normal for most of the southern portion of the United States, including the Southwest. These odds are relatively subtle. You know, the way that these maps are made is you kind of have a 30 equal chances means you have a 33% chance of colder than normal, 33% chance of about normal, and a 33% chance of warmer than normal. So that orange means you just have a little nudge, a couple extra percent for being warmer. Now, if we go to the darker reds, then you start to get into the 60-70% chance, like you've really tilted the odds more significantly. But when I look at this map, I say I think basically that cold pattern that you've had, we're not expecting that to hang on for the whole winter, and chances for being a little bit warmer than normal is probably the better bet. At the right, you can see things kind of being tilting towards kind of drier than normal. This is not a super busy time of year. It's not monsoon season. So I take these slight chances, these slight tilts in the odds with a grain of salt. I don't think they're incredibly meaningful. And then if we extend out a little bit farther for December, January, February, here's where you start to see that the maps look a little bit more like that cartoon for La Nina, where you see kind of better chances for warmer and better chances for drier, kind of consistently across the southern tier of the country, and then cooler and wetter kind of farther north. So we'll hang on to see if this happens. A couple years ago when we had the last La Nina event, you had seasonal forecasts that looked like this, and it actually turned out that Southern California got drenched. And so again, these are just odds depictions where things lean. Don't take them as kind of a deterministic forecast. Okay, if anybody has questions about that, feel free to plop them in the chat. With the last few minutes, I'll just transition and talk about this ASSIST project. The acronym stands for Actionable and Strategic Integrated Science and Technology. And I put in some of our mission statement here, but the goal here was for folks at the U.S. Geological Survey who work on the Colorado River, that's the landscape we're really interested in, to start to work together more, to do more interdisciplinary science. And so the folks who do things like groundwater, and the folks who do wildfire, and the folks who do invasive species, and those who do snowpack, start to work together a little bit more, and also start to have more of a united front when they talk to different resource managers and land managers that have questions about either this year in the Colorado River, or thinking about 20 years from now or 50 years from now. And where some of this project started is we started to look around the survey at the USGS, and we found there's lots of people working on the Colorado River. Publications warehouse is where we put a lot of our journal articles. ScienceBase is a system we have for organizing big data sets, and then just web pages. And so we have hundreds of these across the survey. And if you're a user coming from the outside, it can be really hard to know where to start or to find what you're looking for. So this is kind of a depiction of what ASSIST does, and I really like it. It starts with these kind of drops, because we're very water oriented and very concerned about drought in the Colorado River. And so we have lots of different types of science going on in the survey, but they're kind of separated. And the goal here is, can we start to be a little more holistic, and can we think about the interstitial space between these kind of different drops that represent different disciplines and different research studies? And then can we also deliver it to the folks who are actually on the landscape, the ones who manage real infrastructure, water, forests, species, things like that. And so one of the things that we've been able to, or I guess achievements or milestones so far, is this website, this portal. And we try to use the portal to do a couple of different things. I encourage you to visit it if you haven't already. One, we tell stories about our science, and that's kind of on the left. And I think that's, for general audience folks or folks less familiar with the survey, that's a great place to start. We also have a data catalog where we've tried to take some of these things from ScienceBase as well as from other agencies, where there's big data sets that may depict stream flow or snowpack or future climate or species or remote sensing from Landsat. and try to put those in one place. And then we also try to make this a connection space where different groups can actually talk to each other. It's still a little bit under construction, but it is part of the vision for that web portal. We also have a data viewer that takes a lot of data. This is just a picture of the drought monitor. We already looked at some of this for Arizona, but you can look at things like the drought monitor. You can also look at wildfire activity, some mapping about habitat and species. A bunch of different data layers are available to both view and download. And that's another aspect or thing that we've put on the portal. And then we've put these different science stories, and I'm running low on time, but I'll show, this is just some of the depiction we have that tries to put some synthesis around what happened in the water year 2023. If you remember, 2021, 2022 were really awful drought years and kind of an accumulation of years of dry and hot conditions. So we had a slightly better snow year in 2023. So we put together a web story to say, well, does that really end the drought? And the short answer is no. That we had good snow conditions, but when we start to compare to what the reservoirs are doing, things were improved, certainly, no doubt, but we're still have quite a bit of a deficit in a lot of our surface water supply throughout the Colorado system. So I don't think we're out of the woods in terms of water scarcity in the Colorado, and it would take many years of wet conditions, which I think is kind of an unlikely. We should be planning. Maybe I'll say it this way: planning for maybe a less rosy scenario, because I think the climate likelihood of let's say Lake Mead and Lake Powell totally filling up are pretty slim. We also have another web story about some groundwater work around Tucson, where we looked at the recharge or drawdown in different aquifers around Tucson and did it kind of on a year-by-year basis with some really cool observations that focus on gravity, basically how much mass is in the aquifer. And here are some new projects that are coming out. We'll hopefully in the next year or so, we'll have some new web stories about the effect of dust on snow and how that impacts water resources. This story about kind of long-term aridification versus just ephemeral drought. Some work on sagebrush, not sage grouse, sagebrush biomes and aquatic biomes and how their baselines are shifting with climate change and with kind of prolonged drought, and also doing some economic work around the value of water. Where we're headed, we're trying to get more feedback about the portal. So if you have time to check it out and you have comments about how you might use it, if you have data sets you'd like hosted there, or you maybe have a web story about your work, even if it's not from the survey, please reach out to me. We're also trying to figure out how to make this a more sustainable platform, and how to do more external engagement. We've done a lot of work inside the survey trying to connect scientists, but we really want to talk more with external users. I just want to recognize that this is not my project alone. We have dozens of folks at the survey who are pictured here that are working on this. And if you have any questions about ASSIST or anything else survey related, feel free to reach out to me. Here's my email.
Thank you, Joe. That was excellent. I will go ahead and stop recording, but we'll take any questions. If you have questions, you can put them in chat and we'll see what we can answer for you. So thanks everyone for you. I'm going to stop recording now. Have a good rest of the year.